right, I'm going to kind of plug on. I want people to realize, please, that this is the first class, and I'm going over an appendix. So if 100% of it doesn't sink in, that is to be expected. If single thing I said made sense and you had no problem and could sit there and write it, then you shouldn't be in the class anyway. All right? But we're about halfway through this appendix. I'd like to get through the rest of it in not real much time, before 4:30. And then I want to go through chapter 1, because that's very short, and just talk to you, because it lays out the book. And then show you in chapters 2 or 2 and 3 the kind of projects that they build at the beginning. Again, they're simple. They're very simplistic. But the idea is to show you the concepts, so later when they keep adding stuff on, you're not overwhelmed. Yes. I don't remember. Right. No, I know, but I don't remember. Session timed out. Well, I'm off the virtual desktop now. How's that? It says you can get the raw value for a case by accessing its raw value property. I don't remember. It's in here someplace. All right. Try to remind me of that next class, and we'll look for it. Okay. Now, something kind of different in here. When you set up, this will set up an array of integers, 1, 2, 3, an array of strings, etc. But you can do this. You can set up an empty array. But if you set up an empty array, you have to tell the type. And I can't make it go up anymore because then it'll fly off the page. All right? There's a way to do that. In fact, that might be it there. Maybe that's it. Ah, that's good. Thank you, Stefan. So you can do that. So that will work. But you can't say var integers with nothing after it. Does that make sense? Okay. And this has nothing in it. It is literally an empty array, but it can only hold integers. Okay. Same thing with string, etc. Access the same way. They're zero based. All right. And they're you know, if you'd asked me certain questions, there's at least a chance I couldn't tell you the answer. All right. And some of this stuff has changed. I want to show you something that's changed. It may not look like that big a thing, but I didn't leave during the break, so I want to make sure that I get done at least 5 minutes early, so for you three, I can go up and grab you those Swift manuals. All right, I want to do that, because otherwise I'll just forget to do it. But you see this? It doesn't look like a big thing right here. See where it says 1 dot dot less than 3? Well, I want to show you that, because you may or may not remember this from last time, but if you say something like this, if I say for int I equals 1 dot 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 10, something like that. And I might not even be showing you the right syntax, but what I'm trying to tell you is that will count from 1 to 10. That's inclusive from 1 to 10 with 3 dots. On the other hand, if I do this, with just 2 dots, all right, then it doesn't include the last number on the end. It's exclusive of that last number. So that's 1 to 9. Why am I telling you that? Because when they first put it in there, you needed the less than sign. To my knowledge, you don't anymore. The Swift manual does not show that. But when this book was written, that was what was in vogue for Swift then. So that's one of the things, as an example, that's changed. There are a lot of built-in methods. So, for instance, to add an element to an array, you use the append. A good way to learn a lot of this stuff is to, and this will not work, I don't believe all of it will work in the playground, but when you get in and start actually building an app in Swift. So if we did this, if we said var integers equal 1, 2, 3 like this, and you said integers dot, the IntelliSense is going to kick in, and it's going to show you a lot of the built-in methods that are available to you. That's a great way to learn. Sit there and write yourself a simple program and manipulate the heck out of something. Notice removing things, so you can add. You can add at the beginning, you can add at the end, or anywhere in between. You can remove all, or you can remove at the beginning, or you can remove part, etc. So there's a lot of different things in here that you can use. Arrays, again, in this language, in Swift, must be all of the same type. So you can't mix values like you can in JavaScript, for example. I can't have an array that has booleans in it and floats in it and strings in it, etc. You can't do that. Dictionary. A dictionary, again, is like an associative array because with dictionaries, you've got a key and then a value. A key and then a value. A key and then a value. You can create dictionaries that are empty like this. But again, you have to let it know in the brackets the type of the key and the type of the value. And the key does not have to be a string. It can be anything. You can even make very, very complex data structures where the key might be another dictionary, for example. All right, that's well over my head, but you can do stuff like that. This can be a simple data value here. This could be an object. This could be, for example, an employee number, and that could be all of the employees' information. Name, salary, everything. All right, as an example, you can do stuff like that. And we will get into this stuff as we go on. Okay? Now, what they're saying is, again, this stuff is all based off of NS Array and NS Dictionary. These are Objective-C things. And it's all based off of that. You can, again, you can intermingle Objective-C with Swift. You're going to have a problem because you can do some stuff in Objective-C that's darn near impossible, if not impossible, to do in Swift. And to be honest with you, vice versa. All right. But most of the time, when you can do something in one language, you can do it in the other. Again, most of the time. All right. These are confusing. This is something called an optional. All right. Another thing that will happen, and this is going to sound real simple. All right. But for instance, what if I did this? What do you think would happen if I did that? Nothing, or the program would blow up. Actually, Swift doesn't even like that when you do that. All right? And if you're writing a program, so let's say I'm writing a program, and up here I just say var age, and I don't give it a value. First of all, it's not going to let me do that. Remember I told you that before. All right? But if I do this, if I say var age int, like that, and then where I put the 3 dots here, I've got some code. If I don't give this a value, it's not even going to compile, and if I run that in the playground, it's going to give me an error message. But what I can do, and I want to make sure I give you the right syntax. Let's see. I believe it's like this. I can do that. What that means, if I do something like this, is it means, oh no, don't worry about it. I can assure you that when the program runs, there'll be a value there. They use the exclamation point for that. There's also another one that you can use, which is this one, which means putting a value in there is optional. All right? And you think, well, why would you do that? What if you had some kind of a string value, and you told the person to put in there, for example, we can make it a number. You told the person, for example, to put in their salary. What if they were just hired and they didn't have a salary yet? You wouldn't have a value. You could put a dummy value in there, or say, well, everybody here makes at least 50 grand. So you could do that. But when you work with this stuff, and we will, you'll work with optionals. And you'll see the question mark, and you'll see the exclamation point. So you're going to see this quite a bit as we go on in here. Again, I'm not trying to screw you out of anything in here, not show you different things, but I just do want to get through this stuff that's in here. Some of the stuff that's after this, they go through what is an if statement. All right, my guess is, and I'm hoping that you know that kind of stuff already, but it hasn't changed. Again, you don't need the parens, you do need the curly braces. We've talked about that already. All right? All right. Same thing with a for, don't need the parens, do need the curlies, same kind of thing. Most of the time when you use a for, you can use a for in instead, and you'll write it a little bit less. And if you look at this, with a for in, this is brand new. They've got something called the stride statement. This is almost like, in the past you had to do this using a for loop where you did like plus equals. So if, for example, notice what we have here. Go from 10 down to 0 and subtract 2 every time. So I'm going to do just the even numbers between 2 and 10. So in the old way we did this, we would use a regular for loop, and we'd say something like int I equal 10, I less than or equal to 0, and then we'd say I minus equal 2, something like that. You can still do that. But they came up with this stride statement. And the reason for this, just so you know, is supposedly at least, using a for in breaks down into its machine language equivalent faster than a regular for loop. That's why they came up supposedly with the stride. All right. The do while, no changes except, that look different. No semicolon at the end. Okay, looks a little funky. And again, with the while loop, don't need the parens, don't need the semicolons, do need the curly braces. The switch, we looked at this last year, and again, this I can show you all of it. I know it looks a little weird. Break statement's gone. You can still put them in if you want to. You don't have to. Defaults are not mandatory, always recommended. And notice in here, in the past, when you did this, you would say case 2 colon, then on the next line you'd say case 3 colon, then on the next line you'd say case 5 colon, etc. Can't do that anymore. You have to write it like this. So this says if it's a 2 or a 3 or a 5 or a 7 or an 11 or a 13 or a 19, etc. Do this. All right? It's just the way they changed the language. Not only that, you can do some other stuff. You can use ranges like this. That says from 20 to 30, including 30. You could say 20 dot dot 30, which would be 20 through 29, as an example. You can even come through here, and I don't know if they show it here or not. Again, like I said, that's illegal. You got to do it like this. All right? But you can even come in here when you're working on this. Let's see if they show an example. Yeah. You can come in, and you can, in the middle of your switch, you can literally write conditions. So you can write expressions, and then you can immediately do cases based off of those expressions. They put a lot more power into the switch statement than it used to have. Okay. Functions. The keyword is func. Got to watch how I say that, especially considering this is being taped. All right, it's F-U-N-C, not something that sort of sounds like it, but it's func, followed by the name. Any parameters in parentheses, a return type is shown like this. Minus, greater than, space, and then the return type. I think it doesn't mind if you don't put a space in there. So this says the name of the function is area of rectangle. It requires 2 parentheses, width, which is of type double, height, which is of type double, and it returns a double. Does that make sense? And what's new is if it doesn't return anything, you don't need to put void here. You can if the function does not return anything, whoops, one more, sorry. Yep. You can leave all of that out then. You can say void, but it's superfluous. You really don't have to, but you can. All right. Probably one of the hardest things, and we went over this a little bit in the last class. We talked about it this morning in the PHP class for those of you who were in there. And that's this idea of closures, which they're going to get to. Come on. We're going to get there. And the idea of, I guess maybe I went past it already. Let's see. Yep, while functions and closures. What a closure is it's the same thing basically as an anonymous function in PHP. It's a function that doesn't have a name. But what's so cool about writing closures in this language, and they go, I don't know if this one does, but some of the books go through this whole big, long-winded example of being able to go in there and write something which will take an array, for example, and it'll sort it in ascending or descending order. And what you can do with a closure, to me, for lack of better words, is fairly incredible. All right, I'm trying to show you. So if you write this function, let's sort it equal value sorted, something like this, where you write this. So this would be your function right here. All right, and you say, well, big deal. Okay, well, you could take that, and the system can infer a lot of things for you. For instance, okay, you won't have to say that they're integers. It'll be able to tell. You can break something like this down so eventually it looks just like this. This is really close, And maybe Mike has got experience in it, and maybe the other Mike does. I don't know about anybody else. But that's almost Unix right there. That's the first parameter, and that's the second parameter. And typically in a Unix environment, that will be $0 and $1. All right, for parameters 0 and 1. And that's exactly how they're used here. So what you can do is you can tweak and tweak and tweak and tweak a closure to where you're almost writing no code. And you can get a lot of bang for very little buck. All right. And again, we'll go through a lot of this stuff as we go on. So they go through a simple calculator type of thing for interest. And they start here with this, and they keep breaking it down to eventually where they get to, something that's more like this. Now, it's a little more to it than that, but the idea is that you can write, the system can infer a lot of things. And as long as you're pretty good as far as what you tell it, it'll almost always infer correctly. All right. Classes and structures. These are kind of important things. We talked about structures in the C class last semester. Notice here, structures are reference types. What does that mean? That means that if you pass, classes are reference types. If you pass a class to a function, any changes you make are permanent. See, everybody hear that? Since a class is a reference type, if you pass an instance, all right, if you pass an instance of a class, or you pass the class to a function and you change the class in the function, it's a permanent change. On the other hand, structures are value types. So it passes a copy. So any change you make, you're making to the copy. Don't worry about the ampersands and all that other stuff. We're going to get to all that. All right. One thing you might like hearing right away is, directly at least, there are no pointers in Swift. Indirectly, it does a lot of stuff that way. But directly, there are no pointers. Classes can be subclassed. In other words, you can have inheritance. You can't have inheritance with structures. Here's an example of a structure. Structures, like classes, can hold both values and methods or functions inside of them. All right. Classes, on the other hand, when you want to come in and start creating a class, I'm just going to jump up to that. It's real simple. Class, name of the class, paren. This looks very similar to what they showed before for a structure. And it is, except this is more powerful because you can subclass this. You can base other things off of this. You can make as many structure variables as you want, but you can't subclass a structure where you can subclass a class. So classes are more powerful by default. And again, they're reference types, whereas structures are value types. Properties, as it says, the radius property that they show in there, it says, is called a stored property. We'll get into all this stuff, or at least most of it, as we get going. There still are the idea of getters and setters, in other words, and you'll see that as we go on in here. All right, there's a getter, and there's setters. There's an example. It's the word get and the word set. All right, we'll get into all that stuff, no pun intended, as we go on in here, okay? All right, a lot of people get confused over what's the difference between a method and a function. And in a nutshell, and this isn't the most perfect definition, all right, if you create a function inside of a class or inside of a structure, it's called a method. Other than that, it's just referred to as a function. So that's very simplistic. That might not be the best definition, but it's a very general one that almost always holds true. Chaining, we've talked a little bit about chaining before. When you say something, dot something, we'll get into all that. All right. Finally, the last thing they talk about in here is subclassing and inheritance. And I just want to show you this. Come on. I know there it is. What does this mean? The class is colored circles, colored circle class. It inherits from circle class. Another big difference between Swift and Objective-C and Java, for example, you can create a brand new class. Any class that you create does not have to subclass another class. You understand what I'm saying? I can create a brand new class. We could have just said their class, colored circle class. You can't do that in Objective-C. In Objective C, you'd have to say colored, or class colored circle class colon, you'd have to say something like NS object. You don't have to do that here. And protocols, as it says, a protocol, this is pretty heavy stuff. It's a declaration of a group of methods, initializers, and properties. All right, it says protocols are frequently used to define objects known as delegates. Hopefully what I'm about to say right now makes sense. But again, I've given you this kind of example before, that if I say, you know, I'm really busy right now, Travis, go up to my office for me and grab those Swift things, and I'll tell you where they are, and you do it. And you do it, and I tell you to do it during the break, and everybody else is gone. So he puts them on my desk. Now I hand them out to you. As far as you know, I went upstairs and got them, and now I'm giving them to you. But what I did was I delegated the authority to Travis. He did the work and came back. That's what a delegate basically does, is you're allowed to delegate some of the work, and we'll get into what delegates are. As it says, it provides hooks that allow you to customize the behavior to react. Okay? And we'll get into that stuff as we go on. Hopefully you can tell as we go through this, there's like two more pages here in this appendix. There's a hell of a lot of material. All right, there is. And there's no way that we're going to be able to cover everything. We'll cover as much as we can cover. All right. Extensions, as it says, it allows you to add functionality. These are so cool. What this means, I'm just going to give this to you in a nutshell. Let's assume there's a class that Mike created. Okay? Mike created this class, and he called it person. And it's so good that it was the whole Swift community uses it. John comes now and he says, you know, this is a great class. It's got everything I want except one thing. He can go in and extend somebody else's class and add whatever he wants to do to it. I don't mean inherit. He can literally extend the class to make it do something it didn't do before. That's an extension. That's pretty cool. All right. And that's the last thing they talk about in here. So I'm going to jump back up just so you see this. Chapter 1 that's in here, it's a lot of it's your typical kind of blow-off chapter. They say what you need, that you better go out and you really should register as a developer, and they tell you how to do that. And they tell you that you're going to need OS X Yosemite, and they tell you that you're going to need Xcode at least version 6. They tell you some nice books in here that you can look at to find out more information. And this is kind of cool. What's different about coding for iOS? And they give you a few things here. Only one active application. In iOS, only one active application is active and displayed in the screen at any one time. That should make sense. That says if I've got an app running and the phone rings, typically the app will go into the background. Or depending on the severity of the app or how memory intensive it is, it might even shut down. And that's what they're talking about there. All right. So there's not a lot, there can be multi-threading going on, but the multi-threading that's going on will be going on in the background. All right. Only one window. Desktop and laptop windows, all right, allow many programs to run and coexist. However, unless it says that you attach an external screen, okay, iOS gives your app just one window technically to work with. That's not really true. You'll see that as we go on, but in essence it is. Limited access. All right. iOS seriously restricts what your app can access. It puts you in a sandbox. It tries to protect you from you. It doesn't typically give you the ability to go in. The only person that you can screw up with your app is you. And that's the idea. All right. A lot of places work in sandboxes. Limited response time. Just like we talked about this a little bit last semester in the Android class, in the same kind of thing that if your program is waiting for a response and waiting for a response, depending on the particular program or app, it may even shut down. If it says, if it doesn't get, you know, you need internet access to do something. If you don't get internet access in 10 seconds, it's not worth going on. All right, that's what they're talking about here. Limited screen size, we all know this. And I talked about this last hour. As time is going on, when you look in here, if anything, the screen sizes are getting bigger. All right. Limited system resources, that's not as much of an issue anymore, but still, the big thing about something like this, as opposed to something like this is running on a battery, right? So I've got limited life on this. I can't keep this on forever without plugging it in. And it's also got limited memory because the chip in here isn't as strong as the chip that's in here. All right, but sort of starting to merge together. All right. Some new stuff it says in here. There's a lot of stuff. We'll get into core location. That's, when you think databases, think of that. We're not going to do much work in here. I'm sorry. We just won't have time with cameras and stuff like that. All right. And like accelerometers and stuff where you can shake the machine and whatever. We're going to do very little to none with that. But this is what I want to show you. So this is what I thought. We just did one. Chapter 2, they introduce Interface Builder to you. Chapter 3, it says you build a simple app. Chapter 4, you build another simple app. Chapter 5, this is a cool chapter. You go into auto layout in more depth and breadth of coverage than I've seen in any other book. And you may not think that auto layout is a big thing, but what auto layout does is it makes sure that if you want to center something, everything on your screen, it stays exactly in the center, no matter portrait, landscape, or whatever. Well, that happens anyway. No, it doesn't. All right, and we'll see that. And there's really very little you have to do to invoke auto layout. Now, there you can tweak the hell out of it, but I'll show you 2 or 3 settings that you can set, and it'll basically about 99.9% of the time it'll center everything, for example, on your screen all the time, regardless of where you are. All right. There's some more stuff. Again, table views, which is a big thing. We'll get into some of that stuff. Then when we get into here, so I thought would probably cover like the first 13 chapters. Okay? 14 is on iCloud. I'm not going to cover that. You need an iCloud account to be able to do this stuff. All right? And hell, we have a hard enough time getting the darn software to work on here. I don't even want to worry about iCloud. All right? And this Grand Central Dispatch, the GCD, I wasn't planning on going over that either. I'd like to get into some of this stuff as we have time. So I was thinking 16, 17, and 18. I don't think we'll have time to get into a little bit in core location, but we won't have time for the accelerometer, the gyroscope, stuff with the pictures, internationalization. So what I was looking at was probably 1 through 13, if we go with this book, and then skipping 14 and 15, and then doing like 16, 17, and 18. All right, and I'm not going to lie to you either. We'll be going through it, at least some of it, fairly quickly. All right? It says, are you ready? So in Chapter 2, Appeasing the Tiki Gods, it says, you know what? We don't want to build Hello World, but we're ungodly if we don't build Hello World. So, of course, they build Hello World. So they run you through everything. All right? And it's good. Most of the first programs they do in here, again, are single-view app. Not all of them in here are, just so you know. All right? So they come through here. Okay, and they come through, and I think the first chapter or two, they recommend iPhone, and then most of the other ones that they're going to put in here, they're going to be universal, meaning iPhone or iPad. They use core data until we get to like chapter 15 or whatever the heck that was. We don't check that, all right, because we're not going to be using core data. All right, so we save it. You tell it where to save it. Boom, it builds the folder. It builds all this stuff. This is, you remember this from last semester? Remember this screen, those of you who were in the class? All right. This is the equivalent of the app manifest file that we talked about in Android. It's not the same thing, but it's very close. If you look in here, kind of a weird story, but just so you know it, by default, the orientation, you're supposed to allow for any kind of landscaping, but notice, not upside down. And actually, Apple recommends that you don't have your app work in an upside down format, because they say there might be too much stuff. So if you're constantly, literally, like if you're sitting upside down or whatever, you can still do it, but it might mean the app runs slower. If I want my app to work portrait only, all I have to do is uncheck that and uncheck that. Boom. It won't work at all in landscape then. Okay? Same kind of thing. If I want it to work landscape only, I can uncheck that one. Type of an idea. The toolbar, we've talked about this, but there's new stuff in here, just so you know. Even after we looked at it last semester. And I want to tell you real quick, one of the cool things that's in here, and we can run through this, but not right now. Okay, there's a thing in here, it may not sound like much, but I like it. It's called Preview. So what you can do is you have your, on the screen you've got Interface Builder, if you remember that from last semester. And what you can do is you can open up your assistant editor like we did last semester, but we can tell it to open it up in preview mode, which means it shows you exactly what it's going to look like when it runs. So it might look real pretty on the screen, but you think everything's lined up, and you look at it in preview mode, and you realize that it's pushed over. Instead of being in the middle, it's pushed way over to the left or the right. And as soon as you make a change, and you go back to preview mode, boom, it updates automatically. It's really a nice feature. You can turn it on and off. It literally, you turn it on, you click the X, and it turns it back off again. All right. So regardless, whatever you think of this book, we'll talk about it next time. But if you want a good overview of exactly what's in here and what's in Xcode, Chapter 2 is really well written. It goes through virtually everything that's in here. There's just not enough time to go through it right now. All right? But it does. It goes through every window and everything that's in there. Okay? And again, it has you just literally build the Hello app or Hello World app. That's all you do. They talk about the stuff that's in the object library. They have you add a simple label. And on that simple label, that's what happens. Even though it looked like on the screen, if you look at it in preview mode, that's what it'll look like. So he gives you a real simple way, which doesn't use auto layout, but by clicking a few buttons, you can make a change to it. I'm not going to go through those right now. He starts to get in a little bit into auto layout, but he really doesn't. And he says, okay, so you got to make a couple changes, and then when you do and you run it, it's going to look like this. All right. As you'd probably guess, the more complex your app, the more work you're going to have to do to make it look pretty. Okay. And even in this chapter, they say that if you haven't seen that before, you know what that is? Not Hello World. You know what this is right here, this thing. That's the default icon for any kind of iOS app. He shows you how you can go in there and change it. And God knows, since it's an A-Press book, and you change it, you can probably guess what the icon now looks like. All right. Then I just want to show you this. This is literally what you build in Chapter 3. You're like, you're kidding me, right? No. There's the equivalent of like a text field here and two buttons. And you click the left one and it says left button pressed. You click the right one and it says right button pressed. So you might say, well, it looks really simple. And it is simple, but notice what he's going through in here. He goes through the model view controller paradigm, and he has you build these things very incrementally. He has you just put in a little bit of stuff, and then he tells you why what you just did was important. All right. And again, I'm not going to run through this. We will go through this stuff if we do this one, but not right now. And I just want to show you one more thing, and then I'm done. If we jump all the way up here to Chapter 4, this is the one you build in Chapter 4. So he's got basically a text field here, or a label here, I should say. There's a text field, there's a text field, there's a slider. These you haven't seen before. And when it says switches right there, that's when these things show. When it says button, these go away, and it shows a button right there. He also brings alerts in this program. So when you click something, it's in here. I'd have to go and search there. He shows you how to set up alerts. All right? And here. All right. So he shows you with very simple examples how you can create some really cool stuff. All right? And like I said, these examples in the first several chapters are really simple. They do get harder. By the time you get around to chapter 6, 7, 8, whatever it is, they're more complex. Now that's not you don't build that. No, he's trying to show you portrait versus landscape right there. And the examples that he gives in this chapter, again, for lack of better words, they're kind of silly, but they're so cool in that what he shows you in here. You look at that. All right, he has you just put in 4 labels: upper left, upper right, lower left, and lower right. You think everything's cool. Then he starts to go and change the orientation. And notice, like, where did everything go? And he explains why the stuff gets off, and then he goes into auto layout in a lot of detail to show you what you have to do. So with a lot of it, we'll work through this stuff, regardless of the book we use, but this is auto layout right here. Sometimes all you have to do, all right, is, and there's more to auto layout than what's shown right here, but these are some of the constants. Sometimes it's just setting this. Sometimes there's other things you have to do. Okay, and we'll get into what all that stuff means. I don't know if he shows it in here or not, but notice what he does is he does this, and then he shows you how to make it look right in both formats, type of thing. So, like I said, the code that's in here is simplistic. It's more the ideas that are in here that are more complex. All right. And in here he's going through rotation and adaptive layout. So try to make, as you compress your size of your screen, etc. So like I said, a lot of the stuff that's in here isn't hard. Then this is where it gets a little tougher with the multi-view stuff. No, you don't build that one either. But he's showing you multi-view. All right, he's showing you more examples of a multi-view. And I don't think this isn't even the one you build. But it's the idea that you've got an opening screen and you click one of these and it shows you another screen. All right, so the stuff that you do in here, again, is not difficult. This is the app. You click Press Me, and it takes this blue screen and it brings up this yellow screen. And he shows you how you can iterate back and forth between the two. So what I want to do is try to be fair, to show you some of the stuff that's in it, but let you know the examples are simplistic. The knowledge is phenomenal in the book. It even sounds like it. I'm not trying to convince you. Look at this, all right, and see what you think. All right, so I'm going to stop, and I'm going to go upstairs and grab those for you three, and I'll be right back.